Hello everyone, welcome back to my additional mathematics channel. For today's kinetic motion class, I will share with you different kinds of questions on kinetic linear motion. Let's get started with the class. Have fun! Let's read the question. A particle passes a fixed point O with an initial turn 30. So, we are going to substitute t equal to 2 into the velocity to get the velocity when time is 2. So, the answer is 42 meters per second. For B, where is the particle when t equal to 1? Where it means that find the displacement. In order to find the displacement, we need to integrate the velocity. So, by integrate the velocity, we will get 60 squared minus t cubed plus 30t plus c. So, when t0 as 0, hence the c will be 0. So, when we have the c is 0, we can write again the displacement in terms of the t. So then we will substitute the time, which is 1 second, into the displacement function. So when we substitute and simplify the displacement, we will get the answer for the displacement of the particle at t equal to 1. So the displacement is 35 meters. Now let's discuss the next question. A particle moves along a straight line and passes through a fixed point O. After t seconds after passing O, its velocity v meter per second is given by t is equal to 24t minus 60 squared. Calculate the initial acceleration. In order to get the acceleration, we need to differentiate the velocity. So the answer for velocity is 24 minus 12t. So initial acceleration means when time 0, the acceleration is 24 meters per second per second. So for B, the value of t in seconds when the acceleration is 0. So let's substitute a equal to 0 and we will get the answer for the time. When the acceleration is 0, the time is 2 seconds. Alright, so let's proceed to see the value of t in seconds when the particle is at O again. So when you see the particle go back to the original point, now we need to let the displacement equal to 0. So in order to get the displacement function in terms of t, we need to integrate the velocity. Now let's integrate the velocity. It is 24t squared over 2 minus 6t cubed over 3 plus c, right? So if the displacement equal to 0, that means s equal to 0, the particle is at O again. So by letting s 0, we will get the time by factorizing the function. So 12t squared minus 2t cubed equal to 0. So we factorize the common factor 2t squared. So in the bracket is 6 minus t equal to 0. So we let the factor equal to 0, we will get t equal to 0 and t equal to 6. So when t equal to 0 is actually the starting point, the particle at the point O, and t equal to 6 means the particle actually go back again. Now let's proceed to question 3. A particle moves along a straight line and passes through a fixed point O with velocity negative 12 meters per second and an acceleration of negative 10 meters per second. After t seconds of passing the fixed point, the acceleration of the particle is a equal to m plus nt, where m and n are constant. Now let's see how to solve this. Assume that motion to the right is positive. So when the m and n is unknown, so we need to use the information given. So when t0, velocity is negative 12 and acceleration negative 10. So we will substitute into the m plus nt is equal to negative 10. So we get m is negative 10. So based on m equal to negative 10, we will substitute into the a. A is negative 10 plus nt. Okay, from the a, we need to integrate to get the velocity. So let's integrate the acceleration in order to get the velocity in terms of the t. So velocity is actually negative 10t plus nt squared over 2 plus c. According to the information from the question, the particle passes through the fixed point O with velocity negative 12 meters per second. So it means that when t equal to 0, the velocity is negative 12. It means that the constant is negative 12. So we need to write again, velocity is equal to negative 10t plus n over 2t squared minus 12 before we substitute t equal to 6 into the velocity to find the values of n, because the velocity is 0 due to particle stops instantaneously when t equal to 6. So with that, we can actually solve the value of n. So the n is equal to 4. So hence we can write down the acceleration is actually negative 10 plus 4t. With the m and n, we can get the function for acceleration, and also we can get the function for the velocity. So we are going to list down the function of velocity in terms of t and also the acceleration in terms of t, so that we can solve for the next question. So the acceleration is negative 10 plus 4t and the velocity is negative 10t plus 2t squared minus 12. In order to find the minimum velocity in meter per second of the particle, we need to let dv dt equal to 0. So when dv dt equal to 0, we will find the time when the acceleration is equal to 0. The time is 10 over 4, which is 2.5. It means that when time is 2.5 seconds, the velocity is the lowest. So let's substitute t equal to 2.5 into the velocity, and let's solve the velocity. So negative 10 times 5 over 2 plus 2 times 5 over 2 square minus 12, that is actually the velocity. Okay, this velocity is actually the minimum velocity, alright? So let's proceed to the next question, which is more challenging, is to find the total distance in meter traveled by the particle in the first 9 seconds. So total distance is actually distance from the beginning, t equal to 0, to when the particle stop is at the t equal to 6, and from the particle stop it will actually move to t equal to 9 seconds. So we need to study the movement of the particle before we can find the total distance traveled from 0 to 6 seconds and from 6 to 9 seconds. Right, let's find the displacement from 0 to 6, and also we find the displacement from 6 to 9. In order to find the displacement from 0 to 6 and displacement from 6 to 9, we need to integrate the velocity in order to get the displacement. So if we integrate the velocity, we will get displacement function, which is negative 5t squared plus 2t cubed over 3 minus 12t squared over 2. Then we will substitute the limit from 0 to 6 and 6 to 9. So we will make it positive because this is actually displacement. So in order to find the distance, we need to make it positive because distance is actually always positive. It's a scalar quantity and displacement is a vector quantity. So we need to be very careful when we plus the distance. So the total distance traveled is 189 meters. Now let's proceed to next question. A particle moves along a straight line from a fixed point O. Its velocity v meter per second at t second after leaving O given by v is equal to 2t squared minus 5t minus 3. Find the displacement in meter when the particle stops instantaneously. Stop instantaneously, let v 0, then we will factorize. We will get t minus 3 and 2t plus 1 equal to 0. So we will take t equal to 3 because the times must be positive value, right? So we will substitute t equal to 3 into the displacement function. But we need to integrate the velocity to get the displacement function before we can substitute t equal to 3 into the displacement function. So if we integrate, we will get 2t cubed minus 5 over 2t squared minus 3t plus c. So when t 0, s 0, hence c 0. With the displacement function, we can actually substitute t equal to 3 into the displacement, and we can find the answer for the displacement when t equal to 3 seconds. So the displacement is negative 13.5 meter. So this is actually to the left of the fixed point O. So now let's proceed to B, the range of the time in seconds when the particle decelerates. So whenever we see decelerates, A is always less than 0. So we need to find dv dt by differentiate the velocity. So velocity is given 2t squared minus 5t minus 3. So if we do dv dt, we will get 4t minus 5, which is less than 0. That means that t will be less than 5 over 4 when the velocity is actually decreasing, or we call it decelerate. So for C, the total distance traveled by the particle in the first 6 seconds. So at the beginning, t0, the particle is at fixed point with a velocity negative 3. So it means that the particle is moving to the left. Now let's start with the fixed point O. Let's study the movement of the particle. So at t equal to 0, the particle is starting at the fixed point O. Then when the particle is at the fixed point O, is actually having the velocity negative 3 meter per second, meaning that it is moving to the left. So when t equal to 3, the particle is heading to the left, and of course the displacement will be negative 13.5 meter, right? It means it is at the left of the fixed point O. And when t equal to 3, actually the particle stops because the velocity is 0. So it's actually stopped at the left of the point O with displacement negative 13.5 meter. And at the 6th second, the particle is having displacement. Let's substitute and see. So 2 over 3, 6 cubed minus 5 over 2, 6 square minus 3 times 6, we will get a positive displacement. It means what? It means the particle actually moving from the left to the right, from negative 13.5 meter to the positive 36 meter for the displacement. So in order to find the total distance traveled, we need to study the movement of the particle from 0, t equal to 0, to t equal to 3, which is 13.5 meter. For the distance, it's always positive. And then we have to add with the distance traveled from t equal to 3, which is 13.5 plus the distance 36 meter. So total distance should be 63 meter. Right, let's proceed to question 5. High car play a remote control car along a straight track. The acceleration a meter per second of the remote control car is given by a is equal to 12 minus 4t. When t is in second after the remote control car passes a fixed point O, calculate the maximum velocity in meter per second of the remote control car. So in order to find the velocity function, we need to integrate the acceleration. So let's integrate 12 minus 4t. So we will get 12t minus 4t squared over 2 plus c. So we have to find the c first because the particle is passes a fixed point O with velocity is 0. So then the c will be 0. So we write again the velocity function in terms of the t, and we will let dv dt equal to 0 due to the maximum velocity a must be equal to 0. So let's solve the t. So the t is actually 3 seconds, right? Substitute into the velocity function, we will get velocity which is equal to 18 meter per second. Or B, the values of t in second when the velocity of the remote control car is 0. So we will let the v equal to 0 and we will solve the time. So when the velocity is actually stopped, okay, the velocity 0, the particle stop. So 12t minus 2t squared equal to 0. So we factorize the 2t and let the factor equal to 0. We will get t equal to 0 and t equal to 6. So that is the answer for the time when the velocity of the remote control is 0. Now let's proceed to see the distance traveled in meter of the remote control car in the 5th second. In the 5th second, so we need to find the S5, right? The S5 is, we have to have the displacement function. So we have to integrate the velocity to get the displacement function. So integrate 12t minus 2t squared dt, we will get 12t squared over 2 minus 2 over 3t cubed plus c. Then we will solve the c. When t is 0, particle is at the fixed point, so c is 0. So hence we can say that the displacement function in terms of t is n minus 2 over 3 cubed, right? So then with the displacement function, we can find the distance in the fifth second. Let's use the shortcut, which is s5 minus s4. So we'll substitute 5 into the displacement function one by one, and we will substitute 4 into the displacement function. Be careful, we have to consider the positive value only because this is the distance. So the answer is 40 over 3 meter or 1/3 meter. Now let's proceed to the next question. The diagram on the right shows Azlan running across a street bridge in 25 seconds with a velocity v meter per second. His velocity v meter per second t second after passing through m is given by v is equal to 3 over 4t minus 3 over 100 t squared. Calculate the value of t in second when the acceleration of Azlan is 0 and the maximum velocity in meter per second of Azlan and the total distance traveled by Azlan. Now let's have a look of the movement of Azlan. Alright, so we're going to solve the A. So when the acceleration is 0, we need to differentiate the velocity. So we have to let the velocity equal to 0. So if we differentiate the velocity, we will get 3 over 4 minus 2 times 3 over 100 t, which is equal to 0. So if we simplify the dv/dt, we will get answer, which is E is equal to 12.5, right? So let's proceed to B. The maximum velocity in meter per second of Azlan. Maximum velocity, that means acceleration must be 0. So the time is 25 over 2. So we'll substitute into the velocity to get the value of the velocity. Hence, value of velocity is 75 over 16 or 4/11/16. So let's proceed to the C, the total distance traveled by Azlan. So in order to find the total distance traveled, we need to study the movement of the Azlan. We need to study when the Azlan stopped before it changes direction. So in order to find the velocity less than 0, we have to factorize so that we can find the range of the time when the velocity is less than 0. So we have to multiply by 100 for both sides, and we will factorize the 3t, and we will let the factor equal to 0, and the t is equal to and 25. So for t equal to 25 is actually when the Azlan change direction. So we need to find the displacement from 0 to 25. Alright, so because we don't have the displacement function, so we need to integrate the velocity to get the displacement function, and then we will substitute the time from 0 to 25. So after we integrate the velocity, we get a function of displacement. We will substitute t equal to 25 and 0 into the displacement function. So we will get the displacement for Azlan when time is 25 seconds. Displacement is actually positive, so it's equivalent to total distance, which is 625 over 8 meter, or equivalent to 78 and 1 over 8 meter. That's all my sharing for today's revision on motion along the straight line, or we call as kinetic motion. So till then, I shall see you in my next video teaching. Bye bye and have a nice day.